Now we will see Gauss's theorem in magnetism. So first we have learned Gauss's theorem in electrostatics. What was that? Let's say we have a charge plus Q and surrounding that we are considering a closed surface. So that completely encloses the charge Q. Now electric flux. What is electric flux? The total number of field lines passing through the area. That is E dot ds. The total integral of all. So counting all the field lines that is passing through this area. So these are the field lines for a positive charge away from it. So it's three-dimensional from here in this way. So we are summing up all the field lines and the total value can be obtained by 1 by epsilon 0 times the charge enclosed. Here what is the charge enclosed? That will be plus Q. Now if there are plus Q and 1 minus Q also, what will be the value? That will be 0. Why? So for in this case, integral E dot ds will be 1 by epsilon 0 times we have positive charge and negative charge. The total charge enclosed is plus Q minus Q. So this is 0. Okay. So only charges, see any charge will not make the total electric flux as a positive quantity or a non-zero quantity. There have to be a non-zero value of charge. If the value of charge, if there are a lot of charge and if equal to that number of charge, if you have a negative charge, then the total charge will make 0 and that will be a case of zero flux. Zero flux means total number of field lines passing through the surface is equal to 0. Now I will explain you why this has become 0. The reason was when I had plus Q, there was field lines going out. Let's say there are 5 number of field lines going out. Now the moment I keep a minus Q here, minus Q field lines will be towards it. So 1, 2, 3, 4, 5. So 5 is coming inward. Now I am taking a closed surface. What is the net number of magnetic field lines? 5 is passing out and 5 is coming in. So the net is 5 in, 5 out, 0. So that is the reason for this one. Okay. So that is why we are saying when we are keeping a dipole means plus Q and minus Q at a distance of 2L apart. In a closed surface, the net magnetic flux or magnetic field, magnetic flux is equal to 0. What is magnetic flux? Integral E dot ds. And as per the Gauss's theorem, it is 1 by epsilon 0 times charge enclosed. The net charge enclosed here is plus Q minus Q 0 with dipole. But for any other cases, there will be a non-zero value of electric flux around it. Okay, now let's say we have a positive charge here. Again, I am taking the examples from electrostatics. A positive plus Q here. Now magnetic field lines are going through this direction. Electric field lines. With respect to charge, we have electric field lines, right? Now, when I am taking a closed surface in this way, what is the total number of field lines passing through this? As per the equation, we have the surface in this way. So, E dot ds is equal to 1 by epsilon 0 times. What is the charge enclosed by this? We have a charge here, but that is not enclosed by this surface. That is 0. So, electric flux is equal to 0. Now, what is the reason? Here, see, one field line enters, that goes out. One enters, that goes out. One enters, that goes out. So whatever it is coming inward, that is going outward, making the net electric flux is equal to 0. So if you know all these concepts, then getting the equations, Gauss's theorem in magnetism is very, very easy. Because we know in magnetism, magnet only exists with 2 poles, north and south pole. Now, when we are keeping a magnet north and south pole in a closed surface, it is equal to a case where we are keeping a dipole in electrostatics in a closed surface where net electric flux is equal to 0. Similarly, here from north field lines are going out, but the same field lines are coming towards south. See, south. So the total outgoing field lines are returned back to south, and that is happening inside the closed loop. So the total number of field lines here in this case, what is the value? 0. So with for in magnetism, for every magnet, this will be the same case because every magnet has a north and south pole. So whenever you are constructing any type of Gaussian surface, the total magnetic field lines passing will be 0 because whatever it is going out, the same amount will be returned back to the other pole. Okay. Now I have a magnetic flux, not magnet in this way, north and south. So I'll keep south here and I'll keep north here. So from north, magnetic field lines will be going on. Now when I am keeping an area here, obviously from north it is going in. So 4 are under and 4 are leaving to the other side of the surface. So it's a 0. So if you are keeping magnet inside the loop or even outside the loop, whatever it is, if you are taking the Gauss's theorem in magnetism, the value is always 0. So I can say that the equation is very important. What is the equation? I can see, I can draw here. That is B dot ds is the magnetic flux. Integral B dot ds is always 0. Always. Why? It's a dipole. That will only exist with magnet will only exist with positive, north and south pole. Okay. So this one is the equation for Gauss's theorem in magnetism, and this one is the equation for Gauss's theorem in electrostatics. This can be plus Q or minus Q, whatever it is. So make a note of it. Very important. Thank you.